Algebra 1B. Alright, so what we're going to do today is we are going to talk about the last thing we're doing with polynomials, which is factoring. So far we've taken a look at how to add and subtract polynomials, right? That's what we started off with. We talked about naming them. We've done some multiplying all throughout last week, and this is the last thing we got to do. So factoring is kind of like the division of what we're doing here. So factoring really is just like undistributing an expression, right? So whereas all last week we were talking about multiplying, right? It's like we were distributing pieces into each other. So this time we're undistributing, right? The opposite of multiplying is dividing. That's sort of what we're doing. What we're going to do is we're going to end up with a term that's multiplying other terms in some parentheses. So when we're doing that, we need to be taking out a common factor. So we have these things called trivial factors, which are prime factors. They're things that we can always take out no matter what. And honestly, sometimes they're not super helpful, right? Sometimes, they still could happen, right? But, we want to try and look for something other than the trivial ones. Trivial factors are like, oh, I could divide every number by 1. It's like, well, yeah, we could, but that doesn't do much. So what we're going to be looking for is the greatest common factor. So we want the biggest number that evenly divides several other numbers, right? We're also going to take a look at what that looks like for variables as well. When we're talking about this, though, the evenly divides part is pretty big, right? So for example, we're taking a look at this first one. We want to find the factors of 49 x to the third. If I was looking for something that's a factor of 49, I wouldn't think like, oh yeah, 2. 2 goes into 49, because it doesn't, right? If I divide 49 by 2, I get 24.5 on the other side of things, right? So that doesn't evenly divide. We want things that nice and evenly split the number up. So what we're going to be doing here is we're just going to practice finding the factors first. So to find the factors of 49x to the third, I'm going to start by finding the factors of just 49, right? I'm going to split it up into the number piece and the variable piece. So the factors of 49, right, the way that I like to do them is, I kind of tell myself what I'm working on. And then underneath a little bit, what I'm going to do is I'm going to list out the things that can multiply to give us 49. Right? So there's always 1 and 49. Right? Those are kind of the trivial ones, right? A number times 1, right, is going to result in that same number. We could always do that. Right? But the more interesting one here is that, 49 is the same thing as 7 times 7. Right? So what we've really got is we've got 3 different factors of 49. You could do 1, we could do 49, or we could do 7, right? You might be asking like, oh, why didn't we also select the other 7, right? Because we only need one of them, right? If we have 7 as a factor, 7's already a factor. When we're taking a look at x to the third, right, we can think about it the same kind of way, right? Except this one, when we're doing variables, it gets a little bit trickier, right? So what I like to do is I like to think about like, all right, x to the third, what are different pieces I could break that down into? Right? I could take a 1 out of there. I could divide it by 1 and it comes out the same thing. I could divide that by x. Right? If I take out one of the x's, I'd still have 2 left. I could take out x squared. Right? I could take out 2 of the x's and I'd be left with 1. Or I could even take out all 3 of those x's, right? X to the third. Right? So x to the third actually has those 4 factors. 1, x squared, and x to the third. Right? That's all there really is to finding the factors. Alright, whoopsie-daisy. Let's try it out for 6xy. Right, so again, first I'm going to take a look at just the 6. I'm going to say, alright, 1 times 6 could give me 6. I could also do 2 times 3. Right? And other than that, there's nothing else I can really multiply to get 6. Right, so this one has 4 different factors, 1, 6, 2, and 3. Then we got the x and the y. Right? So with the x's and the y's, right, there's a couple different ways that we could go about it. You could think about them individually. A lot of people like to think about them together. Right? So from x, y, right, kind of similar to the last one, I could always take out just a 1. In this case, I could take out just the x. I could take out just the y, or I could take out the x and the y. Right? So that actually has 4 different things that we could pull out from the variables as well. Right? So those are just finding the factors, but we want to find the greatest common factor, oftentimes called the GCF. Right? So to find the greatest common factor of 2 monomials, right, just 2 chunks, what we want to do first is we want to find the greatest common factor between the coefficients, right? Just the number pieces. Those are the ones that we did a little bit ago up in red. Then what we want to do is we want to find the GCF of the variables, which I'm going to be doing in blue mostly. Right? After that, we just want to smush them together to get the overall greatest common factor for the whole polynomial. Right? And that's the one that we're going to be working with a lot. So let's practice a little bit, right? So we want to find the greatest common factor of these two things. All right, 6xy squared and 18y. So for the 6 and the 18, right, what I can do is I can list out the factors of each one. So 6 we did just a second ago, so 1 and 6, or 2 times 3. To find the factors of 18, I'm thinking 1 times 18 would work. There's 2 times 9, or you could do 3 times 6. And then to find the greatest common factor for those coefficients, I want to take the biggest number that shows up in both of those lists. Right? So in this case, 6 is the biggest number that shows up. So that's what I'm going to take as the GCF of the coefficients. Right? Then we got to worry about the variables. We got xy squared, and then this one over there just has a y. So sometimes this can get a little bit tricky with the variables, right? Let's kind of talk it out the way that we did the earlier ones up there. So we've got xy squared, right? And there's a lot of different things we could take out of this, right? I could take out 1. I could take out just the x. I could take out just a y. I could take out both y's. I could take out an x and one of the y's. I could take out the x and both y's, right? Lots of different things that I could take from there, right? As for the y, right, the other thing that we got to take into account, I could take out a 1 or I can take out a y. Not a whole lot of much options on that one. Right, so again, we're looking for the most we can take that they have in common. Right, so in this case, the most we can take from each one is just a single y. Right? So there is a slightly easier way. Right? This way works, right? If you want to do it out this way, feel free. Nothing wrong with it. But the faster way that I like to think about it is I'm looking at these two sets of variables, just trying to think, how many things do they have in common? Right? They both don't have an x, so I can't take any x's. Right? That's already out the door. When I'm looking at the y's, I'm noticing that this second piece only has one y that it could give up. Right? I know that this first one has two y's, but that doesn't mean that I can take 2 because there's just one that one can give. Right? So when we're looking at the overall GCF for these two things, right, what we're going to do is we're literally just going to smush those things together. We've got a 6 from the coefficients, we've got a y from the variables, our GCF is 6y. It's really all there is to it. Right, after that, what we got to do is we're taking a look at 12x to the third y and 16x squared. So with 12 and 16, right, same kind of deal. Right? 12 is 1 times 12, you could do 2 times 6, you could do 3 times 4. For 16, you could do 1 times 16, you could do 2 times 8, or you could do 4 times 4. And the ones with numbers, right, you know, I was just saying like, oh, there's this shortcut for variables, right? The shortcut for numbers is just kind of getting more familiar with how to do these, right? There's really not a great shortcut way to do it, right? As you get better with them, you can kind of think like, all right, what's the biggest number I could divide each of these by, right? And I'm thinking to myself like, all right, 12 and 16, I can divide them both by 4. Is there a bigger thing? I don't think so. And if we do it out just like we did over to the side here, we are going to find that 4 is the biggest thing they have in common. Right? So that part of my GCF is just going to be 4. As for the variables, let's try and use the shortcut way. So the first piece there is x to the third y. The second one has x squared. Right? So I'm taking a look at the x's first. I'm going to go one variable at a time. I'm noticing that they both have x's. Right? And in fact, they both have at least 2 x's. Right? The first one has 3 x's that it could give away. The second one has 2 x's it could give away. So the most I can take for the variables with the x's is x squared. I could take 2 x's out of each one of those. Right? As for the y, right, the first one has a y, but the second one doesn't. Right? So that means that I can't take anything for the y's. Right? So that means that overall our GCF is just 4 from the coefficients and x squared from the variables. So 4x squared is where we got to leave that. All right. So that was all just finding the greatest common factor. Now we're going to take a look at how to actually do the factoring piece. Right. So our very first step is to just find the GCF, right? Just like we were doing. Right. What we're going to do after that is we're going to divide each term by that GCF, and we'll kind of talk through how to do that when we get to it. Last but not least, we want to put parentheses around the result, right? So we divide and we put parentheses around whatever we get when we finish it all out. And then we put the GCF out in front, right? Because like I said at the beginning, we're doing this kind of like undistributing. We're going to end up with something that looks like a problem from last week with the multiplying. Right? So when we're trying to factor this out using the GCF, I'm going to start by just finding the GCF. Right? So my GCF, I'm going to kind of scooch off to the side here. I've got a 4 and I've got a 22. So for 4, my factors are 1 and 4 or 2 and 2. Right? That kind of limits things a bit. For 22, I could do 1 times 22, I could do 2 times 11, and that is it. That's all we got there. Right? So what I'm doing is I'm just trying to find the biggest number they share, which in this case is just, oops, there we go. In this case is just 2. Right? And I know that as I'm like highlighting these, the 2 doesn't have to be like in the same spot, right? As long as there's a 2 in each one, that is a factor of that thing. Right? So that part of my GCF is just 2. As far as the variables go, right, that first chunk has an x squared, the second piece has just an x. Right? So the most x's I can take overall is just 1. Right? So my GCF is 2x. So hopefully nothing too bad so far, right? We just did the same thing we were doing before. So now comes the new part. What I was saying is that we were going to divide each term by that GCF. And so I'm going to take 4x squared and I'm going to divide it by 2x. I'm then going to also take 22x and divide that by 2x. Alright, so I know that this looks really awful. You're kind of thinking, looking at your screen like, oh my god, this makes me want to barf. Please, no, don't make us do it. It's not going to be too bad. Oops, let's see if I can zoom in a bit. So we're going to just take it one term at a time. Right? So what I'm going to do is I'm going to focus on this 4x squared first. Right? So when I'm dividing 4x squared by 2x, just like when we were multiplying and we matched up the pieces that seem like they go together, this is kind of the same idea. I'm going to match up the pieces that go together. So I'm going to do the 4 divided by 2, which just gives me 2. And so I'm going to give myself a bit of space there, right? Because at the end of all this, we're going to put parentheses and put some stuff in front. So give yourself some room. So the 4 divided by the 2 just gives me 2. When we've got x squared divided by x, right, that little inner piece there, what's really going on is this, right? X squared is x times x, and we're dividing it by x. When we go ahead and we divide things that are the same, right, we can kind of cancel things out on the top and bottom, right? So what's going to happen is one of those just disappears. We're left with just a single x. Right, so this is just 2x. Right? It's kind of like, if you had, 2 divided, well, let's do 4 divided by 2, right? 4 is the same thing as 2 times 2, right? If I have a 2 on the top and a 2 on the bottom, they just cancel each other out. My answer is 2. 4 divided by 2 is 2. Right? Right, so that first part, all taken care of. Hopefully doesn't seem so bad. Then we've got this other piece, right? This plus 22x divided by 2x. But again, same kind of deal. We're going to take 22 and we're going to divide it by 2. That gives me 11. I had an x, and then there's one on the bottom. What happens is that they just cancel each other out. So there isn't an x that goes with that. And you can kind of think about it. Actually, let's do this next part and then I'll kind of go back. So we did our division. I'm going to put parentheses around this, and then I'm told to put the GCF out in front, just like that. Right? So again, we turned this into a problem like we would have seen last week. Right? Nothing too bad. So if I went ahead and did this problem out again, right, I would say, oh yeah, 2x times 2x gives me 4x squared, and then 2x times 11 gives me 22x, right? It spits us back into what we started with, which is perfect, right? One way that it can kind of help to visualize the, like taking the variables out and kind of canceling those, is that, let me use the highlighter here. We had 4x squared, so there were 2 x's there. My GCF's telling me that I'm taking one of them out, so there's 1 left on the inside, right? I had 2, I took 1 out, there's 1 left inside. For 22x, it had an x, I took 1 out, and then there isn't 1 left, right? I took that x that belonged to 22 and I brought it outside the parentheses there. Right, so that's kind of what's going on with that. All right, let's try this next one out. So same kind of deal, right? I'm going to start by finding the GCF. So I'm going to start off with the 4 and the 8. So 4 is just 1 times 4 or 2 times 2. Factors of 8 are 1 times 8 or 2 times 4. All right, so again, the biggest thing that they have in common is what we want to choose, which in this case is 4. All right, so that part of my GCF for the numbers is 4. As far as the variables go, right, this is another one of those ones where it's a little bit on the tricky side. Right? I've got x squared y in the front, and then the second piece has xy squared. All right, so we're going to take it one variable at a time. When I'm taking a look at these x's, right, this one has 2, and this one has 1, I can only take as many as the least one has. I know that that's probably not a great way to say that, right? But this one has 2 x's to choose from. This one just has 1. The most I can take is just a single x. Right? I need to take the same thing from each one. Right? We're looking at the y's, right? This has 1 y. This has 2 y's. Right? So we can only take 1 y out of the whole thing overall. Right? That's all we can evenly take from each one. Right? So same kind of deal as before. Right? We're going to divide everything by 4xy. For somebody that likes to save yourself a bit of writing, you can write it out like this with just one big division sign and the GCF underneath. That's perfectly fine. Nothing wrong with that. Right? If you prefer to have them split up like we just did on number 5, also okay. So when I'm doing this division out, right, again, I kind of want to make sure that I'm leaving myself this space in the front. Right, so 4x squared y divided by 4xy, right, doing this piece here. 4 divided by 4 is 1. We had x squared, we're taking one of them away, so I've still got an x. We had a y, we took it away, so there's no y that goes there. Cool, already done with that first piece. After that, we want to do this 8xy squared divided by 4xy, and we've got to be real careful because there is subtraction there, right? That is a negative 8. So negative 8 divided by 4 is negative 2. We had an x, and we took it out for the GCF, so there's no x. We had 2 y's, and we took one of them out for the GCF, so there's 1 y left over. All right, cool, done. Put some parentheses around that. Throw our GCF in the front for xy. And again, if we did this whole problem out now, we'd end up with the same thing we started with right over here. Okay, that's really what finding the GCF and factoring is all about. Alrighty, so what we're going to do is we're going to keep on going. Number 7. So same kind of deal, except now there's more stuff. Thinking to yourself like, oh wow, this looks like it sucks. Right? So we do have a little bit more to do with the numbers, right? So let's do that real quick. Same old deal as always, except now we've got a 20, an 8, and a 12 to worry about. All right, so factors of 20, 1 times 20, 2 times 10, 4 times 5, and that's it. Factors of 8, 1 times 8, 2 times 4, cool, done. Factors of 12, 1 times 12, 2 times 6, 3 times 4, right? And again, you don't need to do out this little factor tree of everything every time, right? As you get a little bit further into these, you get better at them. You get better and better the more practice you do. That's true with everything, and it's true with math. Right? What I want to do is I then want to choose the biggest thing they have in common, which to me looks like 4. All right, so that part of my GCF is just going to be 4. All right, so the numbers are all taken care of, right? We've got that under control. The variables can also get to be a little bit tricky when you've got all this stuff going on. So first things first, I'm going to look at the x's, and I'm going to make sure that, all right, All of them have x's, so we can talk about, maybe taking some of those. All right, so I'm taking a look. This one up in the front has 3 x's available. This one has 1. This one has 5. I gotta go with the smallest number of those, right? There's only 1 x in the middle, so I can only take 1 x. Right? After that, I'm taking a look at any other variables, right? Oh, cool. There's some y's. But this one in the middle doesn't have any y's. Right? If they don't all share that thing that you're trying to take, you can't take it out as part of the GCF. So we can't take a single y out of these. Right? So our GCF is just 4x. Right? So we'll divide everything, and actually, I'm going to split it up. I'm somebody that likes to write this a little bit split up. Right? Either way, nothing wrong with it. You do you. Alright, so when I'm dividing everything by 4x, right, I'm going to take a look at just this first piece there. Right? So we've got 20 divided by 4 is 5. So that part's all set. We had 3 x's. We took one out with the GCF. There's 2 x's left, x squared. We had a y. We didn't do anything to it, so we still got a y. Cool. That's that first piece already done. Now we'll take 8x and divide it by 4x. Right, so 8 divided by 4 is just going to give us 2. Right? It's a positive 2. We had an x, and then we took it out, so there's no x's there. Cool, done. Last but not least, we got this chunk on the end. It's negative 12 divided by 4 is going to give us negative 3. And then these variables, oh doozy. Right, we had 5 x's, and we took 1 out, so we still have x to the 4th. We still have 4 x's there. After that, we've got y squared, and we didn't do anything to that at all, so y squared sticks around. Last but not least, we put parentheses around the whole shindig, put our GCF out in front, 4x, and that's our answer. All right. Last couple. All right, first things first, same as always, I'm going to look at the numbers, and I'm going to try and figure out, all right, what's the GCF for the numbers? So let's kind of talk through, maybe trying to do this one without writing out all the factors. So I don't know if you guys have noticed in the last couple, but it was the smallest number that had the least number of factors usually, right? And these ones, bad examples. All of them had pretty much the same number. Right? But in this one, if I'm taking a look at 36, 9, and 3, the smallest number is 3 for the coefficients there, and 3 is going to have the least number of things that I could evenly divide it by. Right? So I could divide everything by 1, right? That's the trivial one. We could always do that. But I could also divide everything by 3, I'm pretty sure, right? 36 is divisible by 3. 9 we can divide by 3. 3 we can divide by 3. And so, instead of writing out all those factor trees, if I'm using my brain a little bit right at the start, I know that that's a dangerous thing to think about, Mr. Pog using his brain. Oh no, please, anything but that. Right? Use your brain a little bit at the start, you might be able to save yourself some writing, which is never a bad thing. After that, I'm taking a look at all these variables. Looking at the x's first. Cool, they all have x's, so I can take some number of x's. This one over at the start had 2, this one also had 2, and this one had 3. I'm going with the smallest number, so I can take out 2 x's, x squared. Right. Then I'm going to take a look and see if we can take out any y's. Oh man, this one down at the end doesn't have any y's, so no y's for us. Then we take a look at the z's. Ooh, diggity. We got z's in all of those. Alright, so again, I'm taking a look at how many they have. This has 3, this has 1, and this has 1. The smallest number I can take. Right, the only thing I can take evenly from each is just a single z. Right. So that's our GCF, 3x squared z. Right, so same deal as before. I'm going to take that, and I'm going to divide each piece of this. 3x squared z and 3x squared z. Right. So I'm going to give myself quite a bit of room because we got a decent amount of stuff to write. I'm going to go one piece at a time. Right. So first things first, way over there on the side. 36 divided by 3 is 12. I'm taking a look at the x's. I had 2 x's and then I took 2 x's out, so there aren't any x's left. I had a y, I didn't touch it, so there's still a y. As far as the z's go, I had z to the third, right? So there were 3 z's there. I took 1 of them out, so I've still got 2 left, z squared. This piece in the middle here, right? Again, being careful of that negative, right? That is a negative 9x, right? So negative 9 divided by 3 is negative 3. I had 2 x's, I took them both out again, so I don't have any x's. I had a y that we didn't do anything with, so I still have a y. I had a z, and then I took that z out, so I don't have any z's, so it's just 3y, negative 3y there. Last but not least, we got plus 3x to the third z. So 3 divided by 3 is just positive 1. We had 3 x's, we took 2 out, so I have 1 left over. And then we had that z, and we took it out, so there aren't any z's. And so sometimes when you're doing this division part out, you might be able to turn something gross looking like 3x to the third z into just a single x. Right? That's all that's left over after we take out the GCF. Last step, don't forget to do this on yours. Put parentheses around it. Pop that GCF down in front. 3x squared z. Right? You can notice that my handwriting's getting a little squished in there. Right? So try and make sure you leave yourself room. Some people, even like to write out. They might like say, oh yeah, let's put my GCF out in front, 3x squared z, and then they start their parentheses after that, and then kind of work through the rest of the problem. Right? Either way is fine, whatever works best for you. There's the last one. All right? So if you haven't really paused and tried any of these on your own yet, try and pause on this one. It is quite a bit going on, right? But I believe in you. You can do it. All right? So 54, 27, and 18. Whew. So again, instead of working out the factors for each and every one of these, what I'm going to do is I'm going to take a look at the smallest number, which in this case is 18. So I'm going to think about some factors of 18. I could do 1 times 18, boring. I could do 2 times 9, or I could do 3 times 6. So what I want to do is I want to think through, each of those, which is the biggest thing I could divide by. So I'm going to start with 18. Can I divide 54 and 27 by 18? Not quite, right? I could check it with a calculator, right? But I'll tell you right off the bat, you can't divide 27 by 18. So that one's kind of out. We can't use that one. Can I divide everything by 9? Right? Like going right down the list. 54 divided by 9 is 6. 27 divided by 9 is 3. And we know that 18 divided by 9 is 2. Right? Sweet. So let's use 9 as the GCF for our numbers. Right. Again, something that'll get easier with time, right? If you need to use a calculator to check and see, like, oh, can I divide this number by this? Right? Go for it, right? It's not going to hurt. Sometimes I do it. It's all right. So feel free to use a calculator when you're figuring out your GCF for the numbers, right? It can help. As far as the variables go, right, same deal as before. I'm taking a look and I'm making sure one variable at a time that I take a look at each thing. For these x's, they all have an x, so that's good. This had 2, this had 1, this had 3. I gotta take the smallest and take out 1 x from each of these. All right. After that, I'm taking a look at the y's. Y to the third, y to the fourth, and just a regular old y. There were 3 here, 4 in the middle, and 1 on the end. I gotta take the smallest. Only 1 y comes out of this whole thing. Last but not least, I'm gonna take a look at the z's. As I look at the z's, there's 1 in the front, 2 in the middle, 2 on the end. And again, I gotta take the smallest, just a regular old z. Right, just one of them. So our GCF is 9xyz. So again, 9xyz. We'll divide that by 9xyz. And this last piece by 9xyz. Okay. So I'm going to give myself quite a bit of room here, right? It's going to be quite a bit to write. So 54 divided by 9, right, is going to give us 6. So I'll put that 6 there. As I'm taking a look at the variables for that first bit that we're doing, right, I had 2 x's. I took 1 of them out, so I have 1 x left. I had 3 y's. I took 1 out, so I have 2 y's or y squared left. I had a z, I took out the z, boom, it's gone, no z's. And after that, got this piece in the middle. Again, being careful that that is a negative 27 there. So negative 27 divided by 9 is negative 3. We had an x, and we took it away. No x's left. We have y to the 4th, so we had 4 y's there. We took 1 out, so there's y to the 3rd. We had 2 z's, and we took 1 out, so we've got 1 left. Last but not least, we're almost there. We've got 18 divided by 9 gives us 2. We had 3 x's and we took 1 out, so we've got 2 left. We had a y and we took it out, so there's no y's. And then we had z squared, so we had 2 z's there. We took 1 out, so we've got 1 left. Right, we'll pop those parentheses back around the whole thing. And then right out in front is our GCF, 9x, y, z. Alright, so I know that like when you're approaching these problems, right, say you just skipped to the end of this video and you're like, holy moly, what are we doing? Oh geez, this looks awful, right? These are long problems, I'm not going to lie to you, right? They do take a little bit of time to do, right? But what I'm hoping is that each individual part is not so bad, right? You just take it one step at a time, do them in that order. Find your GCF of the numbers. Take a look at the variables, right? Get your overall GCF down there. Right? After that, you know, even if it's just as much as like writing down this division underneath each one, right? It'll kind of move you in the right direction. Then just take it one piece at a time, right? We're doing 54 divided by 9, and that gave us 6, right? Then we're taking a look at the variables. We had 2 x's, we took 1 out, we had 1 left, right? After that, I'm just moving straight on through, right? We had y to the 3rd, we took 1 out by dividing it, we had 2 y's left. Right, last but not least, we had a z, we divided that out, and then we didn't put a z at the end there. Right? So just take it one step at a time. Right? They are very long problems. Right? They're not going to be quick and easy. It's not going to be like, oh cool, 3 minutes, I did 15 of them. Right? But take your time. Go through the process. It'll be alright. You got this. Right? So as always, be sure to check on Google Classroom for any other resources and or assignments that you got to do. And Mr. Pog is out of here.